If you're in the business of making video games, it's likely that you're going to be dealing with color on a frequent basis. For example, you might want the player character to glow red whenever they take damage, or you might just be creating graphics for games and you want the colors to look just right. In order to work with color with more power, control and precision, it's important to understand how color is made in a digital image. Typically they are made in the RGB color space, which stands for red, green and blue. And what I want to do in this video is to look at what RGB is and how it works, so that you can have the information you need to get started at having real power over your color images. Now, the first thing to appreciate about color images is that really there is no such thing as color built into the image. This image I have in front of me in Photoshop, you can see from the channels palette that we have the red, green and blue channels. Now really these are three separate grayscale images, three separate versions of the same image. We have the red channel, the green channel and the blue channel, and all the pixels in each of these channels do not feature color. They are all grayscale pixels. This means that each pixel in the image will range from 0 to 255. They can be 256 different shades of grey. Notice that it's 256 shades and not 255 because it includes the 0 number. So it's 0 to 255, giving us 256 different shades of grey. If I select the red channel and I switch to the eyedropper tool, you can see in the info panel as I hover over the different pixels that we have, for example, in this black region we have 000 in the RGB component. The 0 value means black, and the higher that we travel along this RGB range, the closer we move to white. So if I move over to this left side of the face, you will see in the info panel that we have 255, meaning that these pixels are white. They are full strength white. Now what black means in the red channel and what black means in any channel is that this channel is fully turned off. There is no strength or color being emitted from that channel. So in the red channel, black means there is no red here. In the red channel, white means that this color, this pixel, is full strength red. Now these three channels, the red, green and the blue, they are overlaid on top of one another, and the output of them is the composite RGB channel, which is shown on screen. The color is produced by the monitor. It is not embedded into the file. The file really contains only the three grayscale channels which are combined together. So what we see here on the left side of the face, if I mouse over it, you can see in the RGB channel we've got 255, this pixel is 255 in the red channel, 178 in the green channel and 163 in the blue channel. So I can switch to red and I will see there it is, 255. I can switch to green and see these pixels are about 178. I can go to blue and see these pixels are 163. So when that combination is mixed and blended together, it gives us this shade on the left side of his face, which is a slight pink tinted red color. It's more red than it is any other color because we can see from the RGB values that red is the strongest component in the color. What I want to do now is create a new image and take a look a bit more at RGB. So what I have created here in front of us is a new RGB image inside Photoshop, and this image is completely black. You will see from the channels palette in the topmost channel, the RGB composite, that what results is a black image, and each of the grayscale channels, red, green and blue, are also black. The blue channel is completely black, which means that no pixels in this channel are emitting blue. The green channel also is completely black, no pixels are emitting green, and the red channel is completely black, meaning no pixels are emitting red. Now each of these channels are grayscale, meaning that they range from black to white. If I wanted to make this image completely red in the RGB composite channel, I could select the red channel, ensure that I select the white color, and fill the red channel with white. Notice that filling the red channel with white results in a completely red image, because now each pixel in the red channel is emitting full strength red. So full strength red, white pixels in the red channel, result in red in the RGB composite. Now if I wanted to, let's say I want to just turn off red, I'm going to fill it with black pixels. Let's switch to the green channel. If I fill the green channel with white pixels, we get again a green image completely in the RGB composite. Let's deactivate the green channel, fill it with black pixels. Let's switch to the blue channel and fill that with white pixels. And again, the RGB composite gives us a completely blue image. Now, of course, if we mix the color blue with red, then we get the color purple, or magenta. So, for example, let's move over to the red channel, and I'm going to fill that with white pixels. Now, the red channel is emitting full strength white pixels, so the red channel is full strength, and the blue channel is full strength. The RGB composite gives us this purpley kind of color. So you'll see that the red and the blue channels are being mixed together on the basis of their grayscale values. Of course, if I set the green channel to white, full strength in every channel gives us the value of white. If I wanted to make the image yellow, for example, then I would want to mix red and green and completely deactivate the blue channel. So I would select the blue channel and fill that with black pixels. And already you can see in the RGB that the image is now yellow because of that color combination. And again, you can see using the eyedropper tool in the info palette that the R component is 255, the G component is 255, and the B for blue is 0. So all of these pixels in this way, you can see how they are being combined to produce all different colors. And this method really is how any RGB image is built up. So that represents the fundamentals of RGB. If you want to find out more information about RGB images, then I recommend checking out my latest book, Game Development Principles. Thank you.